or an object that's launched from a height. Blackbeard the pirate fires a cannonball from the deck of his ship at an angle of 30 degrees above the horizontal with an initial velocity of 300 meters per second. How far does the cannonball travel before contacting the ocean waters if the ship's deck is 8 meters above the waterline? Well, now in this case, we're launching our projectile from above the ground, and it's coming back to a different vertical position. We've got an 8-meter launch height. How do we deal with that? Same thing we've been doing. Let's take a look, and we can say horizontally what we're given. We know V initial in the x direction is going to be 300 meters cosine 30 degrees, which is about 260 meters per second. Final velocity in the x direction has to be the same. No acceleration horizontally, so 260. Delta x, what we're trying to find. Acceleration in the x is 0, and we don't know t. Vertically, let's call up our positive y direction again. V initial y is going to be 300 sine 30, which is 150. V final y, we don't know. Delta y is going to be negative 8, and ay is going to be negative 10 since we called up the positive direction. Let's see what we can figure out here. Well, the first thing I'm going to do is I'm going to see if I can't figure out what the final velocity in the y is. That might be an interesting way as opposed to trying to go and finding t first, which is going to lead us to a quadratic. So Vy squared equals V initial y squared plus 2a delta y. Therefore, 150 squared plus 2 times negative 10 times negative 8 is going to equal Vy squared, which implies then that Vy must be equal to plus or minus 150.5. And of course, if we know it's going up at 150, positive 150, coming down, that must be negative 150. So we're going to choose, using common sense, Vy equals negative 150.5 meters per second. Now I know Vy, negative 150.5 meters per second. Finding the time then, Ay equals delta Vy over t, change in velocity over time. Therefore, t is going to be equal to delta Vy over Ay, or the final negative 150.5 minus 150 over Ay, negative 10, or roughly 30 seconds. So if it's in the air for 30 seconds, that's the same time horizontally. We can solve for the displacement in the x position by delta x equals Vt. Our velocity in the x direction, 260. Our time in the x direction, 30 seconds, equals delta x. So I come up with the delta x value of about 7,800 meters. Same idea, just now in the vertical direction we do have an overall displacement. If it starts here at 8 meters and it ends up here at the water level, it has gone down 8 meters, negative 8 from where it started. All right, one last problem, a nice quick one, and we're done. Kevin kicks a football across level ground. If the ball follows the path shown, what is the direction of the ball's acceleration at point P? Well, here at point P, or any time along this path, it's in projectile motion. The only force acting on it, the only acceleration, is the acceleration due to gravity near the surface of the Earth. 9.8 meters per second squared down. That's all there is to it. Hope that gets you a good start on projectile motion. Thanks for watching Educator.com. Make it a great day.